Problem 6. A ball at the end of a rope of length half of a meter is swung in a horizontal circle with a speed of 15 meters per second. The other end of the rope is fixed in place. What's the height difference between the ends of the rope? So basically, the ball is swung in a horizontal disc, and the disc sagged a little bit because of gravity, and we're asked about this angle that it sags. The solution is alright. It started by stating that for all of the choices, the rope is close to horizontal. Well, maybe answer E isn't quite close enough to horizontal because half of a meter is 50 centimeters. 7.5 centimeters is more than 10% of 50. So perhaps in reality, you will have to solve the problem exactly and at some point take the small angle approximation. So one way to do this might be to start by drawing this diagram and they're realizing it's a balancing force between the centrifugal force mv squared over r over the gravity mg. Take this equation and plug in the relationship that the radius of the rotation is L cosine theta. Put those two together, you arrive at this equation. Move all the angular stuff to the left-hand side, you arrive in here. So this is maybe a point where you can take the approximation. You realize that GL is approximately 10 by half, that's 5, V squared of 15 meter per second is about 225. So 5 is much smaller than 225. Probably at this point you realize that the angle theta is very small, where sine theta is small and cosine theta is very close to 1. So that's that. I will also want to comment on this small angle approximation. It may seem odd for a student because it's not exact, but this is a common approach for physicists working on real-world problems. And I see about 4 to 5 problems in the exam that takes that kind of that line of thinking. Small angle approximation is very common. Another thing is when they say things are moving very slowly, that's a quasi-static approximation. When they say things are moving slowly, they're saying that it's approximately static, and you can assume that all the forces are balanced. There's the net force is 0, things like that. So just need to get used to this kind of physicist talk and be ready to make some approximations.